All right, let's go through this part because we need it for backpropagation, which is how we train the network. And let's look at these one by one. All right, so we're going to use gradient descent to find all the parameters. And there's several layers of parameters, and we're going to find the parameters that minimize the cost function. So here's the formula. It's the same formula, but these gradients are rather complicated. So instead of trying to implement a single formula, he's going to give us a process. And what you do is you compute the thetas layer by layer, and you work your way backwards. You start at the end and work your way to the front. It turns out that if you remember, the derivative of the weights are what you add to the weight to change it. And he writes the derivative of weight theta L is 1 over m. I forget what m is. Well, we'll find out what m is. Times delta L plus 1 as a function of AL. Remember, AL was the output of layer L, and you transpose that. Right? This is a vector because you have several nodes. So it's a vector, and you want to write this as a column vector. So what is delta L? Only for the output layer, delta L equals a to the L minus 1. So here we have AL is this, so that's the output, that's the final output. And Y is the target. Y is the target that is supplied by the user. So you take that difference. Now for the other layers, you're working your way backwards, right? If you have delta big L, then you would plug that into here, and that would give you delta big L minus 1. And delta big L minus 1 is obtained in terms of the weights at that layer. That's a matrix. So you're multiplying that matrix here times the column vector. And then this means element by element multiplication with this here. This is a vector, this is a vector. So you have element by element multiplication of this matrix with this matrix. So, and then we will see an example. So, and then to get to the very end, A1 is the input. This is the input. So you're going to work your way all the way back to the input. Right. So here's an example, hopefully. So how do you make this work? Okay. So first, this was the formula. Now, at the back layer, in this case, capital L equals 4, because there are 4 layers. And you're going to create these deltas, and so delta will be the final A's subtracted and subtract the target. In this case, you have 2 outputs, so the target would be a 2-element. Now, in between, you have this formula, so let's see how the formula works. Okay, so delta 4 was A4 minus Y. You can obtain that because A4 are the outputs of the neural network and Y is the prediction. Then you're going to use this formula to get the d theta. Now see, this is delta L plus 1. So if L plus 1 equals capital L, this is going to be capital L minus 1. In our case, capital L is 4. So we're going to go backwards and find 3. So 3, 2, and 1. You can all get the formula, right? So how do I get delta 3? Delta 3 is going to be this formula here. It's going to be theta 3 transpose times delta 4, which you get up here. And then there's this funny thing here. And this A3 is the output of this layer here. So let's see. So he plugged in the delta, and it's going to take a while to get this. And then he just does the same formula again. The delta 2, this is the formula given here. Then he plugs in what delta 3 is. Delta 3 is from up here. Now, in practice, you wouldn't do the formula. You would compute the delta 3 first, and then you use the result here. So it will be simpler. So that was the case when you don't have the yellow part of the cost function, only the green part. If you want the yellow part of the cost function, you want the yellow part of the cost function, you need to add something. Now here, the issue is that if you remember, you have a bias, which is the theta 0, and then you have the other parts. So the 1 colon means you don't do the first one. You only start from the, you don't do the first component, the 0 component. You start from the second component. Right, because the first component is 0, so here I'm starting with 1. So, all right, so here he goes through the actual process. So you can follow this part. What slide is this? This is slide 18. So I recommend when you try to program this, go to slide 18. If you don't fully understand, just try to follow the steps that he does. The forward propagation you've done, then you want to do these steps. All right, yes. So this one takes care of the green part of the cost function, and then this part takes care of the yellow part. So notice in this step here, when you take care of the yellow part, you take the green part and you adjust it. And you only adjust for the weights from one to the end. And after you've adjusted, you update the thetas. So here he has an example. Let's work through this. All right, so in this case, we have this data. We have 2 data vectors. So these values of x1 and x2, the actual value of the class is 0. For these values of x1 and x2, the actual value of the class is 1. All right, so here's my feature matrix, and here's my prediction. And here's my target vector. So we're actually going to take the transpose of this, if you remember that. To do the forward propagation, we'll take the transpose of this. And let's initialize the weights like this. These don't come from anywhere. He just chose these randomly. And you can see how these weights correspond to the numbers that he put on these edges. For instance, this 0.01, that's going from this node 2 to node 1. And that's in the first layer. So that should be from node 2 to node 1. The from is the columns, and the 2 is the rows. So from node 2 to node 1 is this here. Yes. Okay, so all of these numbers do make sense. For instance, this -1 here is from node 2 to node 1 in the second layer. So that would be in this row here, and this row here, because you start with 0, and it's going to node 1. So all these numbers do correspond to the entries of this matrix. All right, so let's see how backpropagation works. Here's my target vector. And in this case, he's converting to, so he has 2 unique labels, so he should have just 1 output. I'm not sure why there are 2 outputs, since he only has 1 output. So actually, here he has. So why did he do this? I'm not sure, he's actually not doing it the way he said before. Here he has two outputs, but he's using two outputs in his neural network. So he's going to encode 0 as 1, 0, and 1 he's going to encode as 0, 1. So this is the one-hot encoding. This is the new target vector. Okay. All right, so here we have, so forward propagation will look like, so we'll do, this is forward propagation. I'm going to skip through this because you've already programmed this. So that gives me my output. These were my outputs. The first output was 0.5.5, second output was 0.9.4. And these are what are trying to predict the y here. Now, 0.5.5 is ambiguous. I'm not sure how it's going to use that, but this prediction is wrong. So what you want to do is take the delta, which is your prediction, minus your target. You get this. Now you want to compute the delta L backwards. So delta 3 is going to be this complicated thing, but you do have all the pieces here that you need. You do have the theta 3. Those are the existing weights. You do have the delta 4, which we just computed. You have the A, which is the outputs of the second layer, and you have A and 1 minus A. And this is element by element multiplication. So we have to make sure that these two are the same size. So they should work out to be the same size. So you may have to adjust some things to make sure that these two are the same size. When you have element by element multiplication, the two matrices have to be the same size. So in this case, his delta 4 was a 2 by 2. His delta 3 transpose is going to be a 3 by 2. So I multiply this 2 by 2 by this 3 by 2. So if I multiply this matrix times this matrix, what size do I get? Multiply this on the left and this on the right. What's the size of the result? Well, this one has how many rows? 3, and this one has two columns. You take the number of rows of the first one, and that's the number of rows of the product. And then you take the number of columns of the second one, and that's the number of columns of the product. So this is going to be a 3 by 2, which is good because A3 is 3 by 2. So these sizes are going to match.
Wait, are we multiplying delta 4 and...
Well, see what we're multiplying here.
So delta 3 transpose.
Yes, and here's delta 3 transpose is right here, right? So we're multiplying this one first times this one. Okay, and the A3 is this way. He doesn't say it, but this here also is element by element multiplication. This should actually also be a circle dot here, because this is element by element multiplication. So that's what he's doing. So that's how you compute delta 3. And I think in the code he will help you with this. So then you get this result. Then you discard the first row. So you keep going down. Do delta 2 the same way. Here you can see the same thing you have, because your A2 has 1, 2, 3, 4 nodes. So it's 4 nodes. So four values of A. Let's see. So in fact, the first row is always going to be 1s. It's always going to be 1s. And then so these are your weights transposed. So you can do this times this previously computed delta 3. And element by element multiplication, you get this result. And then you discard the first row, you get this. And then now he's going back to delta 1. So in the first slide, he did this level, then he did this level, then he did this level. So you're going to get delta 1 also, same way. and then you use that in your I thought we already did this. So what did we do? Oh, we computed the deltas. No, all right, no, we computed the d thetas. No, all right, we computed the deltas here. All the deltas, and then you use the delta to find the change in theta. Using this formula, the delta times the a. All right, it's a complicated formula, but you should be able to implement it step by step. And then now that you've computed the d thetas, you can now you've computed all the d thetas, you can now update all. You do them all at the same time. All right, so that's, what slide did I start with? I think it was slide 18. So as I said, I would recommend that you open up to slide 18 and look at what he does step by step and make sure that what you do matches what he does step by step. And this is going to take a while, but life isn't always easy. All right, so let me look at your problem, at what you're facing now, and then we'll see if we can get over that. Oh, and I should finish my recording. I'm done with my recording.